This conference will now be recorded. This conference will now be recorded.
Hello students. So we have been discussing the previous year's question paper, JEE Main 2020, 2nd September session. I think this is session morning. So we had already discussed some 5 questions. Now in this discussion, we will discuss few more questions in this session. Okay, so let us start with our first question here. So this question says mass density of a spherical galaxy varies as k by r. That means rho is given, mass density rho is given k by r over a large distance r from its center. In that region, a small star is in a circular orbit of radius r. Okay, so then period of revolution t depends on r. Okay, t depends on r as which one of the given options, like t square is equal to r cube. This is for planetary motion in case of solar, like in case of solar system, actually solar system. But this is not actually for the solar system. It is some other galaxies, okay, where the density varies as this. So you have to find out which one will be the correct variation of time period of revolution with the radius of the orbit. All right, so to do this, like to solve this problem, first of all, let us see what is how do you find out revolution, time of revolution. See, obviously this is actually from the problem from gravitation. Okay, so here in the galaxy, that means you have to write this formula, like you have to write this mv square by r. This is the centripetal force for the revolution of the star in a circular orbit of radius r, which is actually obtained from the gravitational attraction by this galaxy. So that force will be universally, like this is universal constant gm small m divided by r square. So this is the thing. Now this m can get cancelled. Okay, all right. So we can do one thing here. I can write d is equal to r omega. So I'll get r square omega square divided by r, here gm by r square. So this r goes like this. Okay, so omega square will be gm by r cube. Okay, so this is omega square. If I am able to find out omega, which is root over gm by r cube, then I'll be able to find out time period of revolution as t is equal to 2 pi by omega. This I can find out. So this is my aim to find out. So aim is to find out omega. So how do I find out omega? So we have already got the expression. See, omega square is equal to gm by r cube. But what is this m? This is the mass. Okay, this is the mass. I cannot write just like, see, this mass I cannot write 4 by 3 pi. I cannot write RQ row like this. Okay, I cannot write this. So what you have to write? You have to actually find out the mass. Okay, you have to find out the mass. So how to find out the mass? You have to find out the mass. So how to do that? Find out that mass. So that mass could be found out. See, you can just do the integration. So dm is equal to 4 pi r square into dr. Okay. Now if you want to get the whole mass, you can just do the integration. Suppose, so since it is not given the radius of this actually, so what I'll take this, I'll take the spherical object. Okay, take the spherical object of radius capital R itself. Okay, capital R itself. So I can write it here. So dm, oh, this is the volume into rho. Rho is given anyway. So 0 to capital R 4 pi r square dr into k by r. So this r will cancel this one of the r. So 4 pi k, then r dr 0 to capital R. So I'll get 4 pi k capital R square by 2. That means you get 2 pi k r square. Okay, 2 pi k r square. This is the mass. Now look, if I just put it here, then omega square is equal to gm by r cube, right? G by r cube, let us keep it here, and m is 2 pi k r square. So this will be cancelled. So from here omega will be square root of 2 pi k g by r. 2 pi kg by r. Now what is time period then? 2 pi by omega. 2 pi by omega. Sorry, omega. So then from here I can write t square is equal to 2 pi by omega square, which is 2 pi by omega square is 2 pi kg, and this is r. Okay, so you can see t square is directly proportional to r in this case. Okay, but one thing more you have I have considered here, that I have just considered the galaxy as a sphere of radius capital R, and uh, when the star is just rotating near the surface of this. Okay, that means I have taken the radius of the circular orbit of the star is nearly equal to this capital R itself. So that is the thing I have just taken here. So just by taking that, we will get t square is equal to R. This variation we will get. Okay. So let us go to the next problem. So this problem is very, very easy. You see, shown in the figure is rigid and uniform 1 meter long rod AB. So this is 1 meter long rod AB. So this is in centimeter, 100 centimeter. You can see this is 75 centimeter. This is 50 centimeter. This is 25 centimeter. All right. So this AB is held in horizontal position by two strings tied at its ends. So there are two ropes you can see or string here with which the rod is tied, and the strings are actually attached to the ceiling. The rod has mass. See, rod is of mass small m. That means its mass will be actually, its weight will be acting through this. I can write this as mg. Has another weight of mass 2m. This is another weight of mass 2m which is hung at a distance of 75 centimeter from A. See, this is A. From A, it is 75 centimeter as you see here, right? So there is another mass. If I want to write in terms of weight, this is weight 2 mg, and that is also acting in the downward direction. Now the question is the tension in the string A. So in this string, I have to calculate what is the tension. I have to calculate what is the tension at this rope A. So whenever, see, the similar kind of problem can be asked. See, suppose there is a rod or bar which is supported by two uprights, okay, or two supports, okay, two supports. If this is one support and it is supported by another support at the end like this, if it is done, and if you are asked to find out what is the normal reaction at this particular position, okay, so if you want to find out normal position, so suppose this is A, this is B, then you have to actually see, suppose you want to find out what is the normal force at A, then you have to actually pass your rotation axis. Okay, this is actually from, this is the problem from rotational equilibrium. So for rotational equilibrium, so this you have to, this B you have to keep fixed, okay, or you have to pass your axis through this B, and you have to actually find out the torque or the moments for all the forces available, and those moments we have to find out, like we have to find out with proper sign, anti-clockwise, clockwise, etc., and then the net torque or net moment you have to make 0. Okay, at equilibrium, rotational equilibrium, net moment is 0. Okay, look now that I have mass of this itself, this rod itself, along this direction, 2 mg along this. Okay, I'm just considering the rotation about this. I'm taking the axis, rotation axis is passing through B, say. Then see at equilibrium, rotational equilibrium, what I can write for this rotational equilibrium. At rotational equilibrium, look, if I take this as rotation axis, then I have to calculate all the moments about this B. So moment, suppose the tension acting in this direction on this string A, okay, so the torque for this tension about this B will be T into 100. This is the moment, okay, at this particular position, and it has a tendency to rotate it clockwise, and see other ones. See, this one has a tendency to rotate in this direction. This also has a tendency. So this is anti-clockwise moment. This will give anti-clockwise moment. Okay. So I can write 100 into t. This is equal to, at equilibrium, net torque has to be 0. So clockwise and anti-clockwise I can make 0. So from there I can write C mg into 50, and this is plus itself. So 2 mg into 75. Okay, I'm sorry, not 75. It is 25 because it is from B. 25 is this one. Okay. So what you get here? So T will be, say mg, I'll take common. So this is 50 plus 50. Okay, divided by 100. So you get actually 1 mg, or simply mg, mass into, this m is not milligram, this is mass into g. So you get mass into g. So this is the fourth one is the answer here. Okay, let us go to the next problem. This is very simple problem. A gas mixture consists of 3 moles of oxygen, 5 moles of argon at temperature T. Considering only translational and rotational mode, the internal energy of the system is. So a gas mixture consists of 3 mole of oxygen. So oxygen is actually a diatomic molecule, and 5 moles of, so this is oxygen, all right, and argon is actually a monoatomic gas. See, to find out internal energy, you know what it is? Internal energy is half into degrees of freedom F into N into R into T. N is the number of moles, F is the degrees of freedom, and R and T, you know, T is the temperature, R is the universal gas constant. Okay, so this is the formula for internal energy. So each degrees of freedom take half RT. So F degrees of freedom will take half F RT, and for 1 mole, and if it is N mole, then half F nRT. So we have to first of all find out what is this F. For a mixer gas, for a mixer, you know what? For a mixer, you have to find out what is the total mole, okay, mole number, and what is this degrees of freedom for mixed system. Okay, mixed system, here there are 2 gases, so what will be the degrees of freedom of the mixture of the gas? So that you have to find out, and you have to find out the total number of moles after mixing. Okay, and then RT. So in this case, you have to find out the degrees of freedom of the mixture. You know how to find out degrees of freedom of mixture gas? N1, F1, if I have gas, 2 gases, if here actually let me write in terms of notation. NO for oxygen, number of mole for oxygen, number of degrees of freedom of oxygen, then number of moles for argon, okay, and degrees of freedom for argon divided by total number of moles NO plus Na, sorry, Nr. Okay, so this is actually the formula for finding out the degrees of freedom for a mixture gases. for a mixture gas. Okay, so look, to do that, to find out the degrees of freedom for the mixture one, you need to find out individual degrees of freedom of the individual gases. You have to find out. So since it is diatomic, so you can find out 3 into 2 minus 1. So this degrees of freedom is 5, and this is for oxygen. For argon, it is monoatomic gas. So for argon, 3 into, for a monoatomic gas, there is no constraint. There are no constraints. Okay. So now if I say oxygen has got 3 mole, N is equal to 3, NO is equal to 3, and N argon is actually 5 given. So now let us put it here. N oxygen 3, and then 5 is the degrees of freedom of oxygen. Argon, has got mole 5, and degrees of freedom is actually 5. Sorry, 5. Degrees of freedom, what we have got? We have got 3 divided by, so 2 into 3 into 5 divided by, this is 5 and 3, 5 and 3, so it will be 8. So 15 by 4. So degrees of freedom for the mixture is 15 by 4. Now how to find out? So I have got degrees of freedom and total number of mole. Then can we find out internal energy for the mixture? Yes, that is half into F mix into the number of mole, total mole, N oxygen plus N argon, RT. F mixture is 15 by 4. This is 8. So you look here, this is actually becoming 15 RT. So that was, see here, the option is actually, the first option is correct here. Now let us go to the next problem. This is again a very simple problem. So this problem says there are two identical stress strings, okay? Two identical stress strings. This is actually X, and tension in this is X, and another Y. So this is wire X. Suppose another wire Z has tension TZ. Then if the fundamental frequencies are, so fundamental frequency for nu X, so that is 450 hertz, and okay, respectively. So two identical strings X and Z made of some material have tension, made of same material has like both of them have tension respectively Tx and Tz in them. Fundamental frequencies are given. Okay. So fundamental frequency in this case is actually V by 2L, right? V by 2L. Fundamental frequency. Okay, now see how is actually frequency related or velocity is related to this tension. It is somehow T by mu. Mu is the mass per unit length. So frequency also will be proportional to proportional to root T. So Tx is this, and then mu Z proportional to. So from here, actually, what we get, we have to find out Tx by Tz. So mu x by mu z, because they're having direct relationship. So I have to actually find out mu x by mu z. So if you want to find out what is Tx and Ty in terms of this mu1, mu2, mu x square plus divided by mu tau square. So I have got now this. Okay, now it is easy to find out, isn't it? So you have to find out the ratio. So this is 450 divided by, so you have to actually do the calculation part carefully. So there is 300 here into 300 here. So this is actually 40 by 45 by 20. That means 2.25. This is the answer. Okay. I'll just take a short break to just drink some water and come back. So the next question, let us go for the next question. So this question says a charged particle of mass m and charge q moves along x-axis with velocity v naught. When it passes through the origin, it enters a region having uniform electric field E is equal to minus J. That means in the negative y direction. Electric field is there in the negative y direction, which extends up to D. This electric field extends up to D. Equation of path of the electron in the region x greater than D. So this is very simple problem, but maybe it may be a little bit lengthy. Let us see what happens. Suppose at this particular position, when it reaches at this particular position, it has initial velocity v naught. Now it will have to experience an electric field along this direction, okay, because electric field is in the downward direction. That means it will have certain acceleration, since it will have so it will experience a force, and that force will be in the that force will be q into e, like this, in the y direction, okay, in the y direction, negative y direction, okay. So if I take magnitude, so it is magnitude is q into e, and that force will be in the downward direction. So it will have acceleration in the downward direction along y direction, qe by m. So this is the acceleration. So since it has now both the velocities, it will act as like a projectile, even though it had only horizontal velocity initially. So it will actually move both direction, like in the forward direction and also this direction, in the downward direction, okay, since the force is like this, okay. So electric force is acting on it, so its path will be something like this, okay. So I have to find out the equation of path. It will be somewhat straight line, okay, it will be a straight line after this, okay, after this region greater than x is equal to d. So at this region it will be a straight line, but what will be the equation for that? For a straight line, equation is actually y is equal to mx plus c, right? Mx plus c. So what is m? M is the slope and c is the intercept. Intercept, see this point, if I say this, while leaving this region, particle is leaving from this point. So this is actually the c. This intercept I have to find out, and I have to find out the slope. So if I want to find out slope, you look at this particular position, since it is in this direction, it has two velocities, one along this and one along vertically downward direction. So now if I say this angle is theta, if this angle is theta, and say this is Vx along x direction, this is Vy direction in the negative direction, okay. So if I can find out the velocity at this particular position when it is leaving the region, then I will be able to find out tan theta. Tan theta is equal to Vy by Vx. So this is what I'll be able to find out, okay. Vx is V naught itself, Vx here is V naught, okay, that is constant velocity. There is no force in the horizontal direction, so no acceleration in the horizontal direction. So now you have understood, so how to find out this m is equal to tan theta, that I can find out Vy by Vx. Now what is c? How to find out c? If I somehow know the time it takes to come to here, okay. See, I know this. See, if it has to reach from here to here, it is helping. So which velocity is actually responsible for horizontal motion? That is the horizontal velocity. So I can find out time from there, okay. Time is actually, see, d by the v naught. This is actually the time. Okay, v naught is the horizontal velocity, and that is constant velocity. And what is the region thickness or width? Width is actually d. So it will reach at time t at this particular position. So this is d by v0. This is the time. Once I get the time, can I get the velocity vy? Vy, I'll just calculate the magnitude itself. So initially, okay, so vy I can find out ut. So initially along the vertical direction there was no velocity, so 0 plus half a t square. So what is a here? A is qe by m, and what is t? T is d by, so d square by v naught square. So this is actually vy. So vy we have found out vx as well. Vx. So can we find out, can we find out m? M is actually tan theta. So that is vy by vx. So vy we have obtained as q by m, qe by m. T is, so d square by v naught square. So this is actually velocity in the vertical direction, and this is velocity in the horizontal direction. Okay, I hope things are going all right. So let me see what we have got. QE d square by m v naught cube. We have got this now. Okay, let us find out what is c. Mx plus c, right? Mx, x is here. Okay, x is x itself. Mx plus c. I think Vx is V naught, fine. Vt is equal to d, fine. I hope it is okay. So let us go ahead. C is actually the displacement in the y direction, 0 plus half a t square. I see. Actually, there is a mistake here. This is not this. I think this. Okay, so this is v plus ut. Okay, so v is equal to u plus at. A is actually qe by m, and t is d by v naught. So this is actually the velocity. So I think there will be a small change in this. So there will be d by v naught. So this will be d by v naught square. Okay. So C is this, then you look, half A is QE D by QE by M actually. That is a t square. So this half a t square. Okay, I have got this. But you look here, actually if I just take this as origin, so this is in the negative y direction. So I can take this as negative sign. Okay, look then what I get, y is equal to m into x, okay, minus c. So m is q e d by m v0 square minus q e by mv square into d square. Okay, let me just do a little bit of calc. Okay, so this is mx. So QED by mv not square, then x minus d. I think this is the answer. So QED by mv square into x minus d. Let us see whether we have. I see. So there is a 2 here. So this will be d by 2. There is an issue with sign. Okay, so we again we have to take minus here. Okay, I see. This is actually intercept. We have to take as a positive, and here since this acceleration is this minus, I have to take this as minus. Okay, here I have to take the minus. So you will get minus. Okay, with vy. So vy. So ultimately you will get here a minus sign here. And C anyway, you will get a positive sign here. Okay, like this, because slope is going to be negative here. Okay, I just drew like, so this is slope is going to be negative, so that's why slope you have to take negative. So if you take slope negative and this positive, then you get sign reverse here. Sign gets reversed here. D by 2 minus x. So this is the path. Okay, so option C will be the correct answer here. I hope you have understood this. Okay, so this says consider 4 conducting materials of copper, tungsten, mercury, and aluminium. So you have to consider 4 materials: copper, tungsten, mercury, and aluminium with resistivity Pc for copper, Pt for tungsten, and sorry, not P. These are rho resistivity of copper is rho C, resistivity of tungsten is rho T, resistivity of mercury is rho M, and resistivity of aluminum is rho A, respectively. So I'll just give you simple for solution. You have to actually have some idea about this resistivity of mercury. So resistivity of mercury is actually the highest. Okay, 98, nearly 98 into 10 per this ohm meter. Okay, and similarly after that will come tungsten. Rho T will be around 6 like 5.65 into 10 to the power minus 8 ohm meter. And then you will have copper. Copper has 1.72 into 10 to the power minus 8 ohm meter. And rho aluminium. Aluminium has resistivity around 2.8 into 10 to the power minus 8 ohm meter. So you can see mercury has greatest you can say. So you have mercury, aluminum, copper, that is fine. Copper, no, copper is not greater, less, okay. Then aluminum, mercury, no. So first option will be the correct answer here, okay. So we have got another question, and with this we will stop today's session. So a beam of protons with speed 4 into 10 to the power 5 meter per second enters a uniform magnetic field 0.3 Tesla. That means B is given, speed is given. A charged particle, proton, okay, this is a beam of proton which is having speed 4 into 10 to the power 5 meter per second, enters a region, okay, enters a uniform magnetic field. Uniform magnetic field given is 0.3 Tesla. And see, it is making an angle. See, suppose my magnetic field is this, sorry, yeah, let us say my magnetic field is along x direction and velocity is this v. Okay, velocity is along this direction, this is magnetic field. So velocity will have two components, one along, so if this is 60, then we will have v cos of 60, and here v sine of 60. So I will have two components of the velocity of this charge particle, like charged beam or proton beam. So you look here, this, see, this velocity v sine theta, v sine 60 is perpendicular to b. So has tendency, has or gives centripetal force for, okay, since velocity component v sine 60 degree is parallel to, sorry, perpendicular to magnetic field, it will actually experience a centripetal force to move in a circular path, while this b cos theta, which is parallel to the magnetic field, so b cos theta is parallel to magnetic field, this will actually be a constant velocity and it will actually drag towards, like, ahead, okay. So ultimately what you get, you get a helical path, okay, you get a helical path like this. I'm sorry, this is not exactly helical, I'll just show you here. So by the time it comes here, it will move. So helical path means like this, helix. So suppose the particle start from here, by the time it reach at here, okay, in a total time period of revolution, it will actually move forward because of the horizontal velocity, okay. Actually you will get like this helical path like this, okay. So by the time particle comes here, it will actually move up to here, all right. So this is how it will actually make a helical path. So here the question is, the pitch of the resulting helical path of protons is close to, you have to find out pitch. Pitch, you know how to find out, Pitch is the linear distance it travel in a time of revolution. Okay. See, by the time the charge particle make complete revolution, it will actually move in the forward direction. Okay. So the distance it actually moves in a straight line during a time period. Okay. During a revolution is called actually the pitch. So how to find out that length? So you know, in the horizontal direction you have velocity v cos of 60 degree. So this is the velocity, constant velocity. If you know the time period of revolution, so this will give you the pitch. So 4 into 10 to the power 5 meter per second into cos 60 is half. Okay, and time period of revolution, how to find out? mv square by r is equal to bqv. Okay, bqv. So this v goes up. So from here we can actually find out. Actually, we can actually go for, so v is equal to r omega, right? So v is equal to r omega. So these are will cancel each other. So you look what I get, bq by m. So omega is equal to bq by m. So 2 pi by omega is time period. So time period will be actually 2 pi by omega. Omega is qb by m. So 2 pi m by qb. So 2 pi m by qb will be time period. 2 pi m. M is the mass of the proton, which is given actually. So that is 1.6 into 10 to the power 1.67 into 10 to the power minus 27. Okay, let me do the, sorry, I don't have space. I have to do the calculation here itself. So 27. So 2 pi m by qb. Q is the protonic charge 1.69, let us say, which is given. Okay. Q into b. B is given 0.3 Tesla. So all are in SI unit, no worries here. So if you do the calculation, what you should get? So what you should get is four centimeter. You should get 4 centimeter is the pitch. You can do the whole calculation and find it out. Okay. So I'll stop it here for today. And thank you for your patience. Bye.